Okay, Year 12s, welcome back to second video going into Chapter 3. And this is where we started looking at associations between two variables. And in this first video, we're going to go through what happens or how you display the data when both of your variables, both of the two, are categorical variables. Now, obviously, we've got three different scenarios with our variables that we could have when you're dealing with two, in that we've got two types of variables, obviously categorical or numerical. So you've got three options when you come across your particular bivariate data. So first of all, what we're going to cover are two categorical variables. So as an example might be, the one down here is your gender, your sex, and your political views. So, gone too far. Just go back a little bit. Gender and your political views. Both of those are categorical variables. A second option, which we'll cover later on, is when you have one categorical and one numerical variable, so a mixture of the two types. And an example of that might be, say, location, urban, say regional, or remote. So that's a category. We've got the three different categories of location, and say house price. House price would be numerical. So in that case, you've got one of each, and there'll be a particular way that we display that data. And finally, where we spend a lot of our time in core is looking at two numerical variables. So that might be something like, the one that comes up the most is time spent studying and the mark achieved. So that's a nice easy one. We can see both of them are clearly numerical variables, and the only way that we'll display those is in a scatter plot, but that's to come later on. I wanted to cover categorical variables only in this video, and I'll try not to make it too long. If you've gone through all of this and you've read it, you've understood it, and you've done the examples, you might want to either go through it quickly, like in fast forward, or just skip through to where I've done the examples just so you can check your answers. You don't need to sit there and listen to me if you are really confident that you know what you're doing, especially since we did cover this in general maths last year. So first of all, two-way frequency tables. When you have got two categorical variables, this is one of the best ways to display it, because you can actually look for an association from just looking at the table. There's a second way that it can be displayed, and that's in a segmented bar chart, which I'll finish off with. So this is a really good example of two categorical variables. One thing to remember when you do a two-way frequency table, always, is in your columns here, this should be your explanatory variable. So a lot of the time you'll have male, female, you'll have, it could be anything really, but it'll be a category, and if this one in some way explains the other one, if we're investigating whether it does explain the other one, then this one is your EV. The columns are always your EV, and your RV, your response, should be shown in the rows. That's noted up here, but you might want to highlight that if you think you're going to forget. From here, what we can do is you want to read the question carefully and enter information, because you're not going to be given every single entry into this table. You're going to have to work out what's missing. So at a local shopping centre, we have 34 females and 23 males. So what you can do is you go into the columns where the female column is, and in the total you should have 34 altogether, and for male you should have 23. And from there you can even total it up further and go, all right, well, we've got 57 people altogether. Now, they were asked which of the two major political parties they preferred. So they'll have to say one or the other. So 18 females preferred Labor and 12 males. So 18 females and 12 males. So we can total that up. So you're going to total across the row here. We get 30. From here, you see that there is no other information. So it's not given us any of the Liberal figures. But that's okay because we can work it out. As you can see, if 12 plus something has to equal 23, we can work out what is missing. 18 plus something needs to equal 34, so we just go 34 minus 18. And obviously here, we sum the row, but also if we sum these two here in this column, we should get 57. So if you sum down that way, and you sum, add them together, in other words, across that way, you should get this grand total. So that should match. If it doesn't, you've made a mistake. So you need to go back to it. So that is just a standard two-way frequency table. We can also put this into a percentaged frequency table. So we've done something similar to this before, converting to percentages, but just as a reminder, if you want the percentage total, you're looking at it in terms of the column, in terms of, in this example, we want the percentage of females that preferred labour, the percentage of males that preferred labour. So you're looking at, this little thing here will help you. I've tried to make it as clear as possible. If I wanted to get this value right here, I would take how many females preferred labour, so that was 18 of them, and I need to divide that by the number of females that were surveyed. So you're not looking at the number of females in the whole total 57 people, you want just of the females. So in this case, it would be 18 out of the 34 multiplied by 100, we get 52.9. Now what this means is the rest of them must have preferred Liberal, but you can obviously calculate it as well. You can do 16 over 34 times 100 and you'll get 47.1. And we'll see that that totals to 100% as we'd expect. And for the males, you should get 2.2 and 47.8. So I've just gone to one decimal place in this case, as the first entry was to one decimal place as well. So we've got the original data there, and we've put that into a percentage frequency table. But the main concern here is interpreting this. So we've got this data now. We want to answer the question, is there a relationship between these two variables? Is there a relationship between your gender, your sex, and which party you prefer? Now have a look at the two results. They're actually quite similar, 52.9%, 52.2%. So what we can say here is, from this data, no. The percentage of males that supported the Labor Party in this case was 52.2. 52.2% supporting the Labor Party is similar. So when you can see that they are quite similar, there's clearly not a relationship from this data. Just use this language. It's similar to the percentage of females supporting the Labor Party, but always quote the values, as I've done just here. Now, in terms of how big a difference should there be, as a general rule, you want to look for at least 5%. So anything below 5% difference, there's not really a substantial enough difference between the two results that would classify it as significant. We will do, I want you to do a couple of these just to get a hang of them. I'm not going to run you through absolutely every single one. I might just jot down what you should get. So if you haven't done this yet, maybe pause and have a go first. But otherwise, you might like to just run through and check that you've done what I've done. That should be 45 and that would be 41. From here, I've done the percentages. So I'll just tell you this one right here, for females, it's going to be 25 out of the 51 times by 100. So you get just under, just get rid of that. Oops. That's not working. There we go. I'm going to go to one decimal there. Just a note about these totals to 100 as well. Sometimes due to rounding, you can get a result down here that doesn't total to 100. So it might be 100.1 or it might be 99.9. Don't be alarmed if that happens. It's just due to rounding. So it is possible sometimes to have that. This one here, so we should have 12. So I'm just putting the answers in, obviously. You may not have done them in the same order that I'm doing them in here. It's just another element of practice, especially for those girls who've never seen this before. I know I keep saying, oh, look, you did this last year, but I know that some of you did not, and I'm wary of that as well. Okay, so hopefully you've been able to get those, and look, if you do have any problems, please just let me know. Here's another example. We've got attitude towards an upgrade of computer systems. We've got a large corporation, they're going to upgrade the computer systems, and they've gone to administrative staff and technical staff and asked them, do you want this upgrade? Are you for the upgrade or are you against it? So there's all our data, which is explanatory. Well, obviously, because I told you this before, we should always have the explanatory in the column. So that's your first clue, and your RV should be over here. So from there we can go, all right, well, clearly the explanatory would be the area of employment. But you can also see that, all right, we're looking to see if the area where you are employed explains whether you are for or against the particular upgrade. Okay, from here we want this in percentages, so just like you've done before. And if we go to one decimal place here, we'll go 58.9. And that's a 7, and 24. There's our percentages. Okay, in this one, before we get to writing whether there's an association, just have a look at the percentages and you can see that there is a considerable difference here. So here we've got just under 59% compared to 76%, so well beyond our little 5% rule of thumb that we spoke about earlier, 41% compared to 24%. So yes, there's clearly an association between these two variables. So our brief response, quoting the appropriate percentages, will say yes. The percentage of technical staff, so these ones here, in support of the upgrade of computer systems, 76% of them, is much higher than that for administration staff. That's basically all you need to do. Just a note, you just need a single row. So if you've got, this is only 2 rows, so there was obviously both of them were going to be quite different. But if you've just got, say, out of your 5 rows, there's a couple that are considerably different. Generally, you only have, say, of the ones I've seen, there's about 3 or 4 different rows. Really, you just need to identify one single row in which they're clearly different, and then you can state that there's some sort of association. Remember, we're not explaining the association at all. We're just saying that it is there. Looking at the data that we have, there is an association there. Just moving along to segmented bar charts. We're not going to construct the bar chart, but we are going to interpret them. Now, we have done segmented bar charts before, but only when we just had one single column, and that was late last year when we started off this topic. So just a little idea of the progression, I guess, from the raw data to the bar chart. If I'm looking at attitude to number of school holidays that should be given, we're looking at whether students think there should be fewer holidays, the same number of holidays, or more. And we've split this up for our EV, which is primary and secondary school students. Now from there, just like we've done before, we can get our two-way percentage frequency table, as you can see there. And obviously when you're dealing with data, if you can see here how it wasn't the same number of students that were surveyed, so only 47 secondary students, 67 primary. That's one of the reasons as well that a percentage frequency table is so handy, because you can look at it in percentage terms instead of how many. So from here, we can then create something that looks like this. This is a segmented bar chart, and I'll just cover some of the key points. Might just zoom out a little bit. Okay, so first of all, your labelled vertical axis, in this case it's percentage, so obviously it's going to go from 0 to 100%. Your EV So EV is in the columns in your table. You'll notice EV is also in the columns, there it is there, of your segmented bar chart. Notice how each of them are the same height. That's because we are incorporating 100% of those that were surveyed. And the way we break up each little category of the RV is to use a coloured key. So yours is obviously in black and white because I've photocopied it, but you might like to add some colour to it. So there'll always be a key, and that will be our RV, and you should have it either colour-coded or, I don't know, some kind of pattern. Some of you are keen on doing little dots and stripes and things like that. That's fine. Make sure that it's labelled. Obviously, percentage over here, down here, you should have not only the different columns labelled, but also the variable names. So in this case, it was school level, and then the subcategories, primary and secondary. Okay, I think I've covered everything there, hopefully. I'll show you an example. So here we've got a survey. Adults were asked the age when they left school, and that's measured in years, and also where was that school? Was it in an urban setting, a regional setting, or a remote setting? So our two variables are location of last school and age, and you can see the different options in this two-way frequency table. It's actually percentaged as well, as you can see. Now down here, a segmented bar chart is shown. So this is one I've just done on Excel. So you might want to color code this as well, because I know that the colors are a little bit difficult to read on your notes. What I wanted you to do is add the key and the appropriate labels for this. So I'm just going to jump to a different screen so that I can actually just move this down a little bit. I've made it a little bit too large, but we'll manage, just so that I can do the key a little bit better. So what you want to do with the key is you want to, whatever colour that you've used, you want a little square, and you want to show each of those colours on the key, and then obviously you're going to have to work out which one represents what. Now I always like to do mine in the same order that's in the frequency table, but this one I don't believe has turned out that way, but that's okay. Sorry, I'm just trying to match up the colours. There we go. And final one. All right. So first thing, obviously we want to know what is represented by this little blue up here. And if you have a look at here, it's the smallest percentage in the entire two-way table. So this must be the 19-year-olds. And what we can do is we can check the opposite end. They should be in order. You shouldn't have them all jumbled in there. If we check the bottom one, we should have 16.2. Which if you have a look here, yes, right there, it does look like 16.2 about there. So what this is doing is they've put the 15-year-olds are in the bottom, at the bottom segment. So it goes 15, 16, 17, 18, 19. So in our key, just choose an appropriate colour, 15, 16, 17, 18, 19, and we want to label that as well. So what I've done there is not enough. I should also say that this is the age, and that's measured in years as well. Any other appropriate labels that we're missing? We put the key in, but we should also put in this down here, which was location of last school. Oops. And you also notice the labels missing on the left-hand side, and that's percentage. So lucky for us, we're not constructing the whole thing, because as you can see, that would take some time, but it is important that we understand the key features and that we can interpret them as well. Go back to the other one. All right, from here, what we're trying to do, just like we did with the two-way percentage table, is we're trying to work out whether there's an association. One of the things you want to look for is if there is a pattern. So have a look at the different colours. As I progress, as I become more remote, so we've got urban setting, then to regional, then to remote. I'm getting more remote as I move to the right of the chart. Can you see that there is a pattern? And hopefully you can. See how the blue section is increasing. The 15-year-olds, the percentage of 15-year-olds that are leaving school at that age, it's increasing with remoteness. Have a look at, it's a little bit less obvious with the blue because it's so small, the light blue, but with the purple, the 18-year-old school leavers, see how that is decreasing? So I mean, this bit is much larger than that bit, which is much larger than that bit there. That's what we're looking for when we decide on an association between the variables. Oops, I keep doing that. Just get rid of this mess. Okay, so this is what we want to do. Now I've structured what you would say, how you would structure your response, just to make it a little bit easier, and we are going to fill in the blanks. So from the segmented bar chart, we see the percentage of 18-year-olds. So what I've done is picked one of the variables to focus on. We're not going to mention absolutely every single variable because that would be unnecessary. So I've focused the attention on the 18-year-olds. From the segmented bar chart, we see the percentage of 18-year-old school leavers steadily. 18-year-olds. That was the purple. That steadily decreases, doesn't it? The percentage steadily decreases as location of last school becomes more remote. Whenever you make a statement like this, you want to back it up with some percentages. So, for example, the percentage of 18-year-old school leavers in urban schools went from, what percentage for urban schools? 26.5%. And I've said urban schools twice there, I don't know why, to what percentage for regional schools and then what percentage for remote schools. So you're showing, you're quoting that progression, that decline in percentage of 18-year-olds leaving school. So we've got 20.2, then 11.6. 20.2 and then 11.6. This indicates that age when leaving school is associated with location. So we've just had to pick one of them and discuss it, give some examples, and then that's enough. And you'll notice here it says use appropriate percentages from one age group is sufficient. So that's all I've done there. I've just picked one of them and then I've continued. I could have picked a different one. I could have focused on the 15-year-olds. I could have shown that with remoteness, as you get more remote, the location of the last school, we actually had a higher percentage that were leaving school at age 15. So either of those would be fine. Both of those show that there's an association. Okay, just one more, just to really highlight what we need to do here. We've got 3 different types of housing, house, ground level, high rise, and we've got the percentage. Oh, and that's missing an R. I didn't do that, I promise. Okay, so we've got the age, 3 different age brackets, and you're probably thinking, well, age isn't really categorical, but it is when you put it in little intervals like this. So they've put 3 categories of age, and then they've got the 3 categories of type of housing. Okay, is there an association? Hopefully, just like the one before, you can see that there is. There is a bit of a relationship going on here. Here we've got percentage of over 55s in the house. It's decreasing. Ground level units a bit lower, then high rise a bit lower again. Now, in terms of, to be able to actually quote these properly, you are going to have to estimate the percentages here. So what I've done, now here the question says use appropriate percentages from 2 age groups. So what I'm going to do is I'm going to compare these 2. The reason I've chosen these 2 is when you're 0 to 15, you're not really choosing where you're living because obviously you're going to be living with a parent. So I thought that these 2 would be better to compare because these 2 are 2 age groups where the majority of people in them actually have the choice of where they're living. So I did that on purpose, but as you can see, there is a relationship with the other age group as well. So you could definitely mention that one. There wouldn't be anything wrong with that. So I've got my two age groups, but I need to know what these percentages are in here. So if you start with the bottom segment, because you can read really clearly what the percentages are. So this one looks like 35, that looks like 25, and then this one looks like about 14. So I've done an estimate, remember, you just do it to the best of your best judgment. This one looks like about 21. That's from 25 to 6, so that's 40. And this one here is about, this one, yeah, I think that's about right, because that's about 70 or 71. It'll be close enough. Okay, so from here, we're going to use these percentages to help us explain this association. From the segmented bar chart, so you always say this, you always say what you're referring to. See that the percentage of 16 to 55-year-olds, now what could we say is something across the three houses, so it is quite different, I'm going to say. I can't really say in this case that it's steadily increasing or decreasing as we move further out, because that's not really what's happening here. We've got three categories that aren't really, well, they're not ordinal. It's a good example of ordinal and nominal data types. So, for example, it's quite different. So here we're going to start quoting. For example, the percentage of 16 to 55-year-olds living in a house, what is the percentage of those? 21%. It's lower than the percentage in ground level units. So 21 is lower than the 40%. Which is lower again than the percentage that are living in high-rise apartments, and that was 56. So that's one age group that I've shown that's quite different, but I wanted to mention two age groups. Alternatively, it can be seen the percentage of over 55-year-olds follows the opposite pattern. For example, percentage of over 55s living in a house was 35%. That's higher than the percentage that live in a ground level unit, which is higher again than the percentage living in the high-rise apartments. Again, we don't try to say why. We're not going to suggest why over 55-year-olds are not living in high-rise apartments and why they're in houses. Don't attempt to make any explanation as to why. We're simply saying that there is an association. So this indicates that age is associated with type of housing. And that is all that you need to put in your report or in your response. Okay, so thanks for listening to this. I want you to have a go at exercise 3A and B. There are not many questions in there, so I don't anticipate they will take you very long. But again, if there are any problems, can you please let me know? Thank you.